Okay, so now that we've looked at triangles, different types of triangles, we've looked at quadrilaterals and different types of quadrilaterals and properties and stuff. We're going to look specifically at some properties for triangles, two very important ones. The first one is the angle sum of a triangle. And it says that the sum of the measures of the interior angles of any triangle is 180 degrees. That's a pretty powerful property. And if we wanted to kind of just visualize it, we could draw a triangle. And again, it doesn't have to be any specific type. I usually like to draw acute ones, but whatever one floats your boat. And I'm going to number the angles 1, 2, and 3. And again, I want to number the interior ones inside of the triangle. So the measures of those angles should equal 180 degrees. So angle 1 plus angle 2 plus angle 3 equals 180 degrees. And that's it. So again, it's going to be a property that we're going to see in some examples as we go, some different applications. The next one is the exterior angle measure property, which says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two opposite interior angles. So the first question you're probably saying is, how do I get an exterior angle? Well, all we have to do is draw a triangle, but then we're going to extend one of the sides beyond. So that way we get this angle that's outside of the triangle. That's an exterior angle. So let me number 1, 2, and 3 again, and I'll put a 4 for this angle on the outside. So let's read it one more time. The measure of the exterior angle, so this angle all by itself, angle 4, is equal to the sum of the measures of the two opposite interior angles. So these are the interior angles. Which two are opposite that exterior angle? So again, opposite means far away. Which ones are the furthest away from that exterior angle that are inside the triangle? It's going to have to be these two, right? 1 and 2. These ones are the furthest away from that exterior angle. So if we added those two together, that should equal that exterior angle. So that, again, that's kind of a result from this first one. And I could go into the explanation for it and everything, but trust me, it's just true. So angle 4 is equal to angle 1 plus angle 2 from that diagram. Okay, so now let's try it out on a couple of problems. Find the measure of each indicated angle. So we got angle inside, angle inside, angle inside. So we got all three angles inside. So all three of them, remember, have to add up to 180 degrees. So 2x minus 50, x minus 10, and x. All add up to 180. I'm getting that glare again. So let me just shut that light off. Hopefully that makes it a little better for you. Okay, so now what are we going to do next? We got to combine, right? So we got how many x's? We have 2, 3, 4 of them. So 4x minus 50 minus 10 is going to be a minus 60. And so now we can add the 60 to both sides. And so 4x equals 240 divided by 4. So x equals 60. All right, but remember, don't stop there. We got to fill in our angles. So we know this angle here is 60 degrees. 60 minus 10 better be 50. And then the third one, 2x minus 50. So what's that one going to be? 2 times 60 is 120. 120 minus 50 better be 70. So 70 degrees for that one. And if you're not sure if you did it right, just add them up. So we got 70 and 50 is 120. 120 plus 60 is 180. So we're good. All right, so now this one's a little hard to see, but we have an angle inside, we have an angle inside, and then we got this angle that is outside of the triangle. So now we got to use our other property. Now it doesn't matter which side you, or how you write your equation. You could put the 1 plus the 2 on the left and the 4 on the right, or vice versa, the way it's written. So I'm going to put the two angles together on the left side of the equals. So I got 10x plus 15x minus 10 equals 20x plus 25. All right, so now I can do a little bit of combining here. And now I'm going to have to start moving stuff around. So let me look at my x's. I'll move the smaller one. So that gives me a 5x minus 10 equals 25. And now I can add the 10. Which gives me 35. And if I divide by 5, x equals 7. Whew. Okay. All done. No, I'm not done yet. We got to put those back in, right? So 70 is going to be this one because 10 times 7 is 70. So I'll just put a little line here. Let's see. 15 times 7 is 105. 105 minus 10 is 95. And then 20 times 7 is 140. 140 and 25 is 165. So does this one check out? So remember, these two added together better equal that one. And it looks like it works. So we're good. All right. Now the last part of 9.2 is looking at components of circles. So we got a diagram with a lot of stuff all over it. So we're just identifying the different components. So the first thing is the center of the circle. The center of the circle is just a point. And we can kind of see that O is that center. So that's it. O. I mean, if you want to say point O, you could say point O, but it's O. Now, what about a radius? A radius of a circle, by definition, is a segment, a line segment, that goes from the center of the circle to the outside edge of the circle. So, and you want to name all the different radii that are in this circle. It turns out there's 3 of them. So what are those 3 segments? So from the center to the outside edge, so OP, OQ, and OR. And because it's a segment, make sure you put the notation correct. Now you might say, well, can't I write PO and QO? Sure, it's the same thing. So one way or the other, as long as you get those 3 segments listed, you're fine. All right, so there's our radii, or radiuses. That's probably not the right way to say it though, right? Okay. Now, a diameter, by definition, is a line segment. But now, it's a line segment that has its endpoints on the circle, and it passes through the center of the circle. And there's only one. You can see here that PR is going to be a diameter. It passes through the center. Now, remember, you could write a line segment using 2 letters, but you can use 3 letters if you really wanted to. If there's a lot of action going on in the diagram, you could use 3 letters. But 2 letters would probably be enough for this one. So if I said PR, line segment, that would be fine. Or POR, or ROP. So again, you can reverse the order of those letters and it doesn't make a difference. Now, a chord, well, a chord is similar to a diameter because its endpoints are on the circle, and that's it. You don't have any other restrictions on it. As long as its endpoints are on the circle, then that's a chord. So, what do we got in this diagram for chords? Well, PQ is going to give you a chord. Now, even though it has the arrows on it, that's fine, but we want to chop it off at those arrowheads because it's a chord and it's got to be a segment. So PQ is going to be a chord. And is there any other ones? Yeah, there is one more. PR is also a chord. Even though it passes through the center, technically it's still a chord. So be careful with that. They like to try to trick you. So diameters are chords by definition. Okay, so for tangent, by definition, a tangent is a line that touches the circle at one point. So where do we have that happening? Right across the bottom here. We got this line that just touches the circle at one point. So that is a tangent. So RT, and now we do need the arrowheads on our notation. So RT, or TR, is going to be that line. Okay, that's the only one. A secant, by definition, is a line that hits the circle in 2 points. Yeah, so there's only one. And now we do want those arrowheads on there because we want it to be a secant. So PQ, and we got to have those arrowheads. All right, and now the last one, which is the most complicated one, is an arc. So by definition, an arc is an actual piece of the circle. And it could, so you could have different lengths determined by those endpoints of the arc. So we got lots of them in here. Actually, we got 6 of them, 6 arcs. So one arc would be this PQ. So, and the notation for arc is just a curved line over it. So that's one. And you're probably saying QR is another one. That's right. Well, what about this whole big one right here? That would be an arc as well. So we got RP or PR, whichever way you want to describe it. Now, PR, I'm saying, is describing this left-hand side, but what about the right-hand side? What if I wanted to go all the way from P to R on this side? How would I describe that one? That's when you need 3 letters, because now if I put the letter Q in there, that is going to tell me I got to go this direction to get to R. When it's just 2 letters like that, you're taking the shortest path to get from P to R without any stops. So that's why it's the left side. So, but PQR would be the right side. So there's the 4th one, 2 more. Well, these ones are a little bit tricky because they're big. And if I went and started at P and started to go this way and didn't stop at R and kept going, that would be like almost 3/4 of the whole circle. But that's another arc. And by definition, by technical terms, it's a major arc because it's bigger than half the circle. So we got P, R, Q. And again, you can reverse the letters and it's the same arc. And then there's one more. So the last one, well, if we started at R and it went to Q, so it's the 3/4 on the other side. So again, it doesn't matter which order. I like to try to go alphabetical if I can. So Q, P, R. And that's the last one. So I wouldn't get too nervous about the arc stuff. because again, there could be a lot of different things. So to always get every single one of them can be a little challenging, but definitely know all these ones up here. So, all right, and that wraps up 9.2. So we will see you in the next videos.